So in this video, we're going to be trying Linux on our Windows computer. Now there are a few different ways of doing that. You could run Windows Subsystem for Linux. You could run a virtual machine, which means you have a Linux computer in a window on your Windows computer. Or you could try Docker. There's one last option, and that is dual booting. That won't be covered in this video, but you can attend the periodic CSESOC sessions, the Linux Install Fests, for finding out how to install Linux and Windows on the same computer. First, we'll be looking at Windows Subsystems for Linux, or WSL. So this is a great option if you have a Windows 10 computer that is updated, so you'll need the anniversary update. If your Windows is up to date, it will work. Alright, so how will we do this? Well, there's just a couple of steps. First, we need to check if our computer will be able to run Windows Subsystem for Linux. And that is not too complicated. We'll go to the file browser, go to this PC, Properties, and we'll have a look here. And the first requirement is that we have a 64-bit computer. So we look under System and System Type, and we've got a 64-bit operating system right here. So that will be perfect. We also want to check if our Windows build is greater than 14393. But you don't have to worry about this too much as long as you keep your Windows up to date. Alright, if you don't have Windows 10, as a CSE student you can download that for free. You can see how to do that here. We're going to open up a browser. And all you have to do is Google Taggy Windows. And Taggy is the wiki for CSE. Lots of information available there. Jump to this link here. Available software, Microsoft Windows operating system. Alright, from here we can go to this section. We want to go to the Imagine Web Store. Click this link here, CSE Imagine Web Store. Alright, then we can choose Select Products, and we'll ask you to log in. So you want to log in with your ZID and also your email. So it'd be at ad.unsw.edu.au, and then you want to use your ZPass. Now, assuming that you have a 64-bit Windows, and that's Windows 10, an updated version, now we'll go through the steps for installing Windows Subsystem for Linux. Alright, step 1. Open up Settings in here. So down here we go this little notification action center thing here, and we'll choose Settings. Alright. Now we've got our settings panel here. We want to go to Update and Security. It should be right down the bottom. Updates and Security. Then we want to go to the For Developers section. That's down here. Now these settings are intended for development use only. That's okay because we are developers. Let's choose Developer Mode. Turning on Developer Mode, including installing and running apps, could expose your computer. That's alright. Alright, so this will take a little time as it searches for the stuff that it needs to download. Alright, so that's step 1. Step 2. We have to go to Turn Windows Features On or Off. So let's right click on the Start button here. Right click and go to Programs and Features. Now in the side here it has Turn Windows Features On or Off. and choose this one. It will take a little while to be populated. Now we want to scroll down here to Windows Subsystem for Linux. We want to tick this one. Alright, then we'll click OK. Alright, so we note here that Windows needs to reboot your PC to finish installing the requested changes. So let's restart now. Now that we've restarted, we're ready for step 3. Click on the Start bar and search for PowerShell. Now we have Windows PowerShell up here. What you want to do is you want to right click on that and choose Run as Administrator. We'll choose yes. And you want to type the following command. Enable Windows, that's a capital W by the way, capital O, optional capital F feature, dash capital O online, capital F feature, capital N name, Microsoft Windows Subsystem Linux. Alright, once we've got that, hit enter. And we'll set that up for us. There we go. Alright. So that's the 3 steps. Now we have Windows Subsystem for Linux installed. So, how do we use it? Well, go down to the Start menu here and type cmd. That will give us the command prompt. Alright, and we can snap that to the side here. And at the prompt, we can just type bash. Now it'll ask us if we want to enable the beta feature. This will install Ubuntu on Windows. And we want to choose yes, we do want Ubuntu on Windows. So that will then download. Alright, and then when it is done, it will ask you to create a Unix user account. So it's going to exist separately within your Windows computer. So you want to think of a username and a password. And in my case here, I'm just going to use my ZID as the username and my ZPass as the password. That way it's easy to remember. So don't worry about when you type and nothing appears. It is accepting your input, it's just hiding your password so that nobody can look over your shoulder. Alright. So when that's done, we now have a Linux system. We can type ls, we can cd into our folder, we can tab complete, we can clear the screen, we can even use text editors like Vim, or Nano. Cool, alright. So there's one more thing we can do to make this a little nicer. You notice right now it has a very long line Z55555, 55 at desktop, etc., etc. And then it has this long path MNT C users Callum Howard, etc. Now this is because it's set aside part of the drive of your Windows computer and it's putting all the Linux stuff there, right? But you'll notice, normally on a Linux system, when you cd and press enter without typing anything, you will go to the home folder. However, if we do this now, we will go to a folder that is, we don't really know what's there, right? If we print out the working directory, it's just home Z555555, right? We might want our home folder to be related to a location on our Windows machine, right? So I'm going to link that up with our folder, which is in C users, my user account, and comp1511, right? I'll have all my labs in here and my assignments too. So I want to set that as the home folder. How we'll do that is with the following command. We want to create a symbolic link, and that will be ln-s, and you can just copy this, mnt c users, and then you want your username, so basically whatever appears up here, right? And so that will be my name here, then comp1511, alright, closing quote there, and then we want that to be mapped to this folder, home slash the Linux user, so that's the number, that's the username that appears before the @ symbol here, right? So Z and then 7, yep, and then slash comp1511, which is this folder here, right? So these two folders are going to match up. There we go. So now if we ls, we will see we've got comp1511 here. And if we cd into comp511, we'll see that it gives us the path ~/comp1511. The tilde stands for the home folder. So in the home folder in comp1511, we have our folders, and this matches up here with this. So if I was to make a new file here, lab02, we would see this change reflected here. Alright, and here's a little tip. If you ever cd into a folder which you don't mean to cd into, right? We'll go up a folder here, cd ... to go to the parent folder. To go back to the last folder that you are in, you can type cd-, and that's the minus sign. And you'll go back to the previous folder. Alright. So there's one last thing I want to show you. And that is, if you want a nicer terminal where you can edit the fonts and the backgrounds and the colors, right? There is an option for this. This terminal is quite good, but we can do better. This is an optional step. So if we go to the web browser and we Google CMDER, grab this first link here. It's an alternate terminal emulator for Windows, and as you can see, it does look quite nice, right? So all we have to do is download here, and this full download will come with lots of useful utilities as well, which you might learn about later. So once that's downloaded, we can open show in folder, so we can see where it is. It's a zip file, so we want to extract it. And extract all, and then I'll choose Commander 4. Alright, now that's extracted, we will have a folder with the following files. We might want to make a shortcut on the desktop so we can get back to the terminal emulator. So what we can do is right click on CMDER here and select Create Shortcut. There we go, and that will create a shortcut. Then we can move this shortcut to the desktop, which will allow for easy access. Alright, so all that's left to do is to open this version. Alright, and then there you have it. To snap it to the side, just drag it to the side here, and we'll snap to the full screen. And then, don't forget, to run the Windows subsystem for Linux, you want to type bash. There we go. So now that we've got Windows subsystem for Linux, I will quickly show you how we can compile and edit our work. So if you watch my previous video, you may have seen that we can install various text editors. We will need a good text editor unless you're using one that's built into the terminal, like Vim or Nano. So let's use Gedit. I have Gedit already installed, so I'll just search for Gedit. There we go. And I can snap that to the side here. Alright. We want to open. We want to open the file I prepared earlier. Users Howard in 1511 hello.c. Alright. Now we've got our file, we can add compiled in Windows subsystem for Linux! Exclamation. Alright. Save that. Now if we look in our folder, and this would work in the normal command prompt as well. Everything I'm doing now will work in the Windows command prompt. Alright, then check that we're in the right folder. We will run gcc wall, then choose our output to be hello, and specify our source file to be hello.c. Alright, so we will get the message that the program GCC is currently not installed. You can install it by typing the following. So we want to do exactly that. We will type sudo apt get install GCC. And we'll ask for our password. And note, this is the password that you set for the Linux user, the Unix user inside your Windows system. Alright, then we can just hit enter when it asks, or we can hit Y, and it will go and download GCC. Now we're done, and it's important to note that we can do this in this CMD-ER, or we can do this in the Windows command prompt, CMD. It will work exactly the same way. CMDR is just a nicer looking version of the command prompt. It does the same thing. Alright, so now that we have GCC installed, we can clear the screen and then go to our previous command by hitting up and up again, alternatively Control P and Control N to go down and up, next and previous. And we'll go to GCC wallware -o hello.c, and this time it will compile. And then to run it, we'll do the usual /hello, and it will run hello world. And then we'll also say compiled in WSL. There we go. Forgot to put a new line in. Never forget your new lines. So that's it for running Windows subsystem for Linux. We've looked at installing it, and then installing GCC, and then using it, linking it to our Windows file system, and then compiling a program. Alright, so we're up to the Docker section. And for whatever reason, WSL is not good enough for you, and you don't want to run a virtual machine, there is the option of using Docker. Now, what Docker will do is it will allow you to have what's known as a container which has Linux inside it, and that container can run on Windows. So we'll look at how to do that now. The first thing to note is this requires a 64-bit operating system. So as before, you want to double check and make sure that your operating system is 64 bits. We can do that by selecting our PC and going under System, System Type, 64-bit. There we go. Alright. So the next step is to download Docker. I can do that by going to our web browser and then searching for Docker Windows. Alright, we can check the first link here, which will give us download links. We want to install Docker for Windows. Alright, download Docker for Windows. We can just get the stable one. It doesn't matter too much which one you get. Alright, and we'll open that up. So we want to proceed through the installer and just accept. Alright, and we can choose Launch Docker. So each time you want to use Docker to compile your programs, you're going to need to make sure it's running, and you'll know if it's got the little icon down here, whether it's running. If it's got this animation that's playing, it means it's starting up. It can take a short amount of time to start up. Once it's started, then you can use your Linux container. Alright, it's telling us now that Hyper-V feature is not enabled. We do want to enable this feature, so we're going to say OK, and it will automatically enable it and restart our computer so that feature is enabled. Alright, now that the computer is restarted, we can start Docker once again. Alright, now even while it's starting, we can change some of the settings here. Go to the settings, and we'll choose, you can check whether you want Docker to start when you log in. I actually prefer to start it myself, because that way it uses less system resources when I'm not programming. Alright, now if we look at under the Advanced tab, we can reduce the amount of memory it will use. And that is good because by default it can be set to use 4 GB of memory, and that may be all your computer has. So you might want to set it down. I think the minimum is 1 GB of memory, and that will be sufficient for running simple C programs. Alright, the other thing you want to do is check shared drives, and under here we want to select the C drive. We want to make that shared so that Docker can use it. So once we've done that, we want to hit apply, and it will update that. Alright, it's done. So don't worry if Docker takes a while to start the first time, that's alright. So we can close that now. We're ready for the next step. So the next step is to open a command prompt. So click the Start menu and type cmd. And get the command prompt. In the command prompt, we can try running docker run hello-world. And if we're able to run this, that means everything is working correctly. Okay, so hello from Docker. This message shows that your installation appears to be working correctly. So that's good. Docker is working. So now we can get into the good stuff. There's a special Docker container set up for computing with the CSC systems. And we can run it like this. We go docker run -it. Now the IT means interactively, right? That means we can keep running multiple commands, not just one command, and then quit. Then -v, and what the -v will allow us to do is set up a mount, and what that means is we can access our Windows files inside our Docker container, inside the Linux system running inside our Docker container. So it's not too bad to do that. Alright, so we have in quotes here, we want to type this path that we see, right? So C : /users / Howard, and that will be your username. And then we'll have a : /root. So what that is saying, and then we'll close the quotations there. What that is saying is we want this path that is before the colon to map to the path that is after the colon in our Linux container. So C uses the user folder, that's going to map to /root. That's what we want. Okay, then after that comes the name of the container, the image that we want to run. So it is comp1511/sh, and it will, if we press enter there, it will download the comp1511sh image. If you've already downloaded it once, it will not need to download again. It looks to check if it is already on your computer before trying to download it. Alright, now that that is finished, we are put into our Docker container. So basically we have a Linux system right here. We can the only one thing is that you can't clear, but anyway, so let's change into our folder comp1511, and we have our lab folders here. We can cd into lab 01, and we have our files here. Now because we have full Linux here, we can edit in a command line text editor, or we can, if I move this and snap this to the side here, by dragging it to the side, we can open it in a folder and see the files that we're editing. And we can, as previously, use a Windows text editor to edit our C files. Alright, so here I've got Atom open. And we can change this to be compiling in a Docker container. Alright, now let's try compiling that. I'll save it. File, save, and also do Control S. Alright. GCC hello.c. Alright, and that is compiled. And so if I run hello, that will work just as expected. Okay, so one thing to note is that we have we've looked at several different Linux systems, and it is not guaranteed that a binary created with one of those will work in another one. There's a good chance that if you're using the WSL Windows subsystem for Linux, Ubuntu, it may work in another Linux system like a Docker container based on Ubuntu. But it's best to assume that you have to recompile on each new system that you use. And that includes the CSE environment. So if you're ever getting errors trying to run your program, just double check that you compiled it on the system that you're currently on. I've made that mistake before. Alright, now we want to see how we can transfer our files up to the CSE environment. Now you could use WinSCP as before, There's also other similar programs like FileZilla, which will also work, but we want to see how to do it from the command line. Now note that you can SSH into your CSE account from the command line right here. Right? So if we type SSH at csc.unsw.edu.au and press enter, it will ask us for our password, and we want to use our ZPass here. Alright, and we're into our CSE account. Let's just check here. We have some files. Let me just move that first. Alright, so we can exit out of that to go back to our Docker container. And imagine that I have completed my lab exercises, and they are in the folder called Lab01. I want to move that whole folder up to CSE because I want to then finish it off on a lab computer and then hand it in. What I can do is use the following command, scp. It's like SSH for the copy command. So scp, and we use the flag -r. -r means recursively, and that means it's going to grab, we can use that for folders, and it will grab everything inside the folder as well as the folder itself. Alright, so we go, first we want to put in the source and then the destination. So what we want to move is lab01, and where we want to move it is the CSE environment. So what we're going to do is put in our username and then at the host name, so z555 at cse.unsw.edu.au, and then now that we've got our username at hostname, we want to put a colon, right? And we want to say where is the destination on the lab system where we want to put the file. Well, we can put tilde, which means the home folder, and then slash. So tilde/ is the home folder, and if we run this command, it will move the lab01 folder up to the home folder on our CSE account. And let's see that now. So it will ask for our password. And it will give us progress on each of the files it copies up. And really here we only need the .c file, but it's just for illustrative purposes. Alright, now I can SSH into the account. And if I list the files here, we'll see that lab01 is now on the lab system. We can cd into lab01, and we can compile our file again on the CSE servers. Alright, so that is how to set up Docker, edit text, and transfer using the command line in Docker. To exit Docker, you can just type exit. And to exit the command prompt, you can type exit again or hit the close button. Alright, so that's it for the video on how to run Linux on your Windows computer. Thank you.